Right. Soroush was apparently born in Iran, not the US. And I think the one interesting fact about him is that he had an iPad app in the App Store on the very first day. So that was like what, 10, almost 10 years ago now?
That was honestly,
yeah. Awesome. So yeah.
Yeah, that was April 2010. So feels like so long ago. Cool. Hi, everyone. I'm Soroush. Last talk of the day. I know everybody's tired. So we're going to have a really light talk, no code on screen, you know. We're not going to have to think too hard. Just kidding. I have 200 slides, and 90% of them have code. So strap yourself in. Okay, so here's some code that I really like. What this code does is it's a network client. So it takes requests, and it sends them, and it decodes the JSON response and returns it. So if you want to step through this code sort of line by line to figure out what it does, you can kind of look through the main body of the main function of this class, and you see that it creates a URL request. It uses the URL session to send that URL request. It checks the status code and makes sure it's between 200 and 299. And if not, throws a status code error. And then lastly, decodes the JSON. So there's one other thing about this code that you should know about, which is that it uses promises and it uses generics. These are a little bit more advanced features, but they just exist to make the code look a little bit nicer. If you don't understand those things, all this code will still make total sense to you. So I really like this class. I think it's a good class. And why do I think it's a good class? Well, the main reason is that this class is testable, right? So how do we know that it's testable? There's a couple of little things we can look at that tell us that it's testable. So one thing is that it only has one singleton in it. That one singleton is the URL session. So if you could sort of mock out that URL session, maybe by wrapping it in a protocol, you can inject that into your initializer for this class, and then you can go about and test this class. So it's dependent on only one singleton. That makes it a little bit easier to test. The other reason that I know this class is testable is this big, fancy, complex word called cyclomatic complexity. So what is cyclomatic complexity? Cyclomatic complexity is branches. So how many branches does this code have? Well, let's step through it. So the first branch is what we call the happy path. This is if nothing goes wrong. So we create the URL request, send it, check the status code, and decode the JSON. Nothing went wrong. We went through the code as sort of expected. The other three branches that we're going to look at here are all errors. So one is the network error. We create the URL request, send it, and then it immediately errors out, and we don't run any more code. Then there's a status code error. We create the URL request, send it, check the status code of the error, and it turns out it's, let's say, a 404. And at that point, it throws an error. And then the last branch we have here is a JSON decoding error. So again, we create the URL request, send it, check the status code, and then try to decode it, and that's when it fails. So we have these 4 branches. And with these 4 branches, that means there's basically 4 tests we have to write to test this code in its entirety. So that is why this class is very testable, right? We like that. So this code is good. I like this code. But good code doesn't stay good. You have to add another thing to it. Your project manager comes and says, hey, we need another feature here. Can you add this? You say yes. And then, the sales team comes and says, hey, we need another feature. Can you add this? And of course, you say yes. And slowly, as you add these features, they say, well, our API has authentication, so can you add authentication into this? Sure. Well, we find that the system is actually killing our app while there's still network requests. Can you add some background task stuff? And you say, yes, I can add that too. And then later on down the road, one of your PMs comes and says, well, we don't support the network activity indicator. Can you add that feature? And you say, yes. So you add that feature in there. And after a while, you realize this class has gotten totally out of control, right? What happened here? We had this beautiful code, and it did one thing, and it did it really well. And now we have this code that does so much more. And so where did we go wrong here? Well, one way we went wrong is we violated the single responsibility principle, right? So if you look at the code, and while the code is zoomed out like this, you don't need to read the code, but just look at the colors, right? So we have one purple responsibility here, we have another orange responsibility here, And we have another light blue responsibility here. So this is now a bunch of extra stuff we've added to our class. We can take a look at that cyclomatic complexity again. And I'm going to run through how much complexity we added here. We can talk about the individual cases, and if you want to know more about them, you can find me later, but let's just run through and see what we added. Well, we added a check up there, whether it's not equal to 0, that's 2 cases. There's 2 more cases here, 3 more cases here, 4 cases from our original code, and 2 more cases at the end. These are all the different branches that we can run through. And does anybody have an idea of how we could combine these numbers to find out what our total cyclomatic complexity is? Does anybody have a sense? Multiply, exactly. So this code that you think has just gotten bigger has done something much worse, and it's exponentially gotten worse. Because as you add these branches, you have to multiply all these cases. And so if you want to fully test this new class that we've written, you need 96 different tests. Okay, that's a far cry from the 4 that we had before. This is way too many tests. Nobody's going to write 96 tests for this. This is not good. Another way we know that this class is sort of started to fail us is, again, if we look at singletons. Right, our previous code had 1 singleton in it. This code, it has all these singletons in it. These are all different. If we wanted to do the same sort of strategy as before, extract these singletons, we could kind of pull them out towards the top, and then we could sort of wrap, right. Yeah, we'd extract all these to the top. We would wrap them each in a protocol exactly the same as we did before, and then we could inject fakes using an initializer. Again, this is horrible, okay? You don't have to live like this, all right? You deserve better than this, okay? And what we're going to learn today is we're going to learn how to take code that was bad and make it good by using abstraction, right? So we ended up in this situation where we need to abstract some code out, right? And why are we in that point now, right? The reason that we're in that point now is because the code has grown, and the code has gotten more complex, and the code has become too hard to test, too hard to work with, too hard to add new features to, right? It's not because we just feel like adding an abstraction seems like a nice idea. It's because we really are running into concrete problems with the way our code is, right? So if we want to abstract this code, there's kind of a guideline that we're going to follow. First step is we need to find the similarities in the problem, right? So one way we could look at this code that we have is we could say, well, why don't we look at it and break it up by time, right? There's 3 different points in time here. One point is this first step, which is where we add headers to our request. The headers can happen way before the request is sent. This can happen really whenever. The next kind of phase of time is right before the request gets sent. So this is, we need to kind of grab a lease on a network, on a background task identifier. We need to like increment our activity counter and all that. That needs to happen right before we send the request. And then the last phase, of course, is what happens after the request is received. So these are the 3 sort of ways that we can slice up our code. And we can kind of extract everything out to the top and break things down and wrap this code up. But when we do that, we run into a problem, which is that when we get our background activity identifier, that identifier needs to be used in both the before section and the after section, right? So this code happens early in the process and then also late in the process. So we're going to have to take this piece of state, and we have to move this piece of state around, and that's going to be a bit challenging. It's possible, but it's not fun. So this is an important way to think about the code in terms of before and after and the headers and sort of this time direction. But maybe there's a different way that we can slice up our code. And if we can slice up our code in this different way, then maybe we can use that to kind of develop our abstraction. So we have this, we have the headers, we have the before and the after. But let's look at a different thing. Let's look at what it would look like if we slice this up by responsibility. So we looked at those responsibilities earlier. We have the purple one, we have the orange one, and we have the light blue one, right? And this doesn't run into any of the problems that the other code did with respect to state, so we can kind of extract out some classes to the top and then sort of replace this code. And again, we're just looking at the vague colors here of how this stuff is changing, right? We're going to zoom in and actually look at how this code looks in a little bit. But basically, when we kind of think about this approach, we see that this can actually work for us, right? Our state is kind of hidden away and it's only used in one class, so we don't have to pass it around too much. This can work. So once we have an abstraction, or once we have a similar, like a dimension of similarities that we can understand, then at that point it's time to actually start thinking about what the abstraction is going to be. So now's the point where you're going to start being able to read the code again. You have these sort of three colors which represent these three responsibilities that the code has. And again, we can use that time slice to sort of break down what this code actually does, right? So this first section here, the purple line, that's just adding headers. Again, we can do that well before the request starts. We can do that anytime we want. This next section of code, which is setting up the backgrounding identifier and incrementing our network counter so we know how many network requests are in flight at any given time. Those all have to happen right before the request gets set. And then last we have our after section, which is to sort of clean up all the stuff that we've done. So these are our sort of time slices. And if we take these time slices and we kind of make their names, the names of those functions that we're calling a little bit more generic, then we can maybe get somewhere. So right now all these things are very specific, right? Add headers to, set up backgrounding, increment counter. But these can become more sort of abstract and more general, and once we can kind of think about them in terms of the time that they occur at, then we can start cleaning things up. So backgrounding.setup becomes backgrounding.before, counter.increment becomes counter.before, and likewise for the methods that happen after. We've kind of cleaned this up, and now all of the code in the sample that we were trying to like slowly bring out and slowly get back to our original good thing that we had, now sort of responds to all the same messages. So that's good. So we have the green stuff, which is any headers that we need to add. We have the blue stuff, which is anything that needs to happen right before the request, and the red stuff, which is anything that happens after the request is over. So if we take those three messages, we can turn those into a protocol. And so this I'm calling request side effect for now. This is essentially what these things are, right? It's like something that you need to happen in addition to the request. It's not the main thing that the request does, but it's this extra thing that sort of needs to happen. And we just take our three messages from before and put them in this protocol. And while request side effect works for this specific set of things that we want to do, we can maybe make this name even a little bit more broad and capture some more ideas in there. So I'm actually going to go ahead and rename it to request behavior. So this is a behavior that happens when you fire a request. So going back to our code, now that everything, now that these sort of, the bits of extracted code all correspond to the same protocol, we can wrap everything up in that protocol. And here's where the sort of magic starts to happen, right? So because the types of all three of these variables, right, auth token and counter and backgrounding, because they all correspond to the same type, right? Each of those variables has the same type. They have the type request behavior. We can actually just treat them as though they're the same thing, right? And so we can actually, instead of having three separate things, we can have one thing, one array of three things that all get treated the same, right? This is the magic of the whole thing right here, is when you can wrap this up and treat all three of these totally different responsibilities as the same, that's when the magic happens, right? And why is that magical? Because we can kind of go through the same little trick as before. We can take our behaviors and we can sort of inject them, and then we can move this out. We can move it out of the class entirely, and now it's become sort of a configuration that we can kind of put into our network client whenever we want. So that's really cool, but I'm going to unwind this and leave us with this code right here. And so now that they're all in an array, then we can start to change the code to actually work with that array. We check all of our behaviors, and we add all the headers they need. We check all of our behaviors, and we run the before code. We check all of our behaviors and run the after code. And so now the main body of the send method has no idea about auth tokens. It has no idea about any kind of behaviors. All it knows is there's an array, and I get to work with that array, right? So this is pretty good, and this is the protocol that got us there. But now that we've kind of seen the protocol we want, we can tweak it a little bit, make it better. Add headers isn't bad, but we are dependent on this extra type here, this URL request, which means that anybody who is looking at this and any code that works with this has to know about URL requests, and that's not exactly ideal. So we can go and replace that and just make it a dictionary of strings to strings and just call those additional headers. Any request behavior can add additional headers. Before was a good name when we were kind of originally working with this code, but now that we've kind of seen what it does, before wouldn't necessarily make sense in every situation, so let's go ahead and name that something a little bit better, before send. And after is good, but after doesn't let us differentiate between after success or after failure, after what happened, right? And so we can actually split that up into two methods, after success and after failure, so that we can handle errors and successful responses separately. So this is kind of where our protocol, the direction in which our protocol is going, which is pretty good. I want to add one more thing here, which is kind of a nice thing to have, which is that you can make this after success method throw, and this actually allows any request behavior to sort of halt the process and say, you know what, actually that data might look right to you, but I know more than you, and that data doesn't look right to me. So you can actually add extra validation this way, and that can be really nice. And so that is sort of the process of developing the abstraction that we want to work with. And at this point, I want to take a sort of sidebar, and I want to talk about this phrase that we use in programming a lot. So the phrase is don't repeat yourself, DRY. Now, show of hands, who's heard of this? Good majority of the people, almost everyone's heard don't repeat yourself. This is something that we teach to programmers very early on because it's a very easy rule to teach, right? Don't repeat yourself means if you see two things of code that look the same, maybe they should be the same, right? But don't repeat yourself can kind of get us into trouble in a couple different ways. Well, one way is that don't repeat yourself couldn't get us to this abstraction that we found, this request behavior. Don't repeat yourself looks for bits of code that look similar rather than underlying fundamental concepts that are similar. And those are the really important things. So if you look at sort of this grid of code that might look similar and code that really functions the same, right? If you have code that doesn't look similar and doesn't behave similarly, that's fine. That's most code. Most code's not going to get abstracted, and that's A-okay. And if you look at code that does look similar and code that functions similarly under the hood, well, that's fine too. You've probably already, quote-unquote, abstracted that out, and that code was very obvious and needed to be sort of deduplicated. So that's good. But what about these other two quadrants of this box, right? So if you have code that looks similar but isn't actually the same under the hood, you end up with a false positive. And this false positive is so painful. The more you program, the more you'll run into this of code that was sort of abstracted too early. It was abstracted before the person who did the work had a sense of really what that code was doing. You'll find, this is if you find a function that's like, well, add an extra boolean on the end to like control some flag behavior, to like flip this back to the other thing, and then add another boolean 2 months later, and you keep adding booleans to this one function, and all of a sudden it has 10 parameters, and you're going crazy. That's this red box here, right? You will run into this problem. And the last red box is something where the underlying concepts are the same, but the code looks different. Don't repeat yourself cannot solve this problem, right? And this was the problem that we solved today. So this is the sort of ripe for abstraction place that you want to be. So this is code that doesn't look similar but actually can be abstracted out, and this is what we've done here today. So don't repeat yourself is good. It gets you really far, but at a certain point, don't repeat yourself is going to get you into trouble. There's a quote by a developer by the name of Sandy Metz that I really like. I like the developer and I like the quote. It is, duplication is far cheaper than the wrong abstraction. If you set something up with the wrong abstraction, then you are going to find yourself in a world of pain. And her recommendation is actually just completely unroll the abstraction and then look at it again and see if there's another abstraction there for you. So duplication is far cheaper than the wrong abstraction. This is where don't repeat yourself fails. This is where DRY fails. So that's sort of step 2 of the process, right? We've still got a lot of stuff to go. Just kidding. We're getting there. We started to develop the abstraction, and at this point it's time to start making some tools that will help us work with the abstraction a little bit better. So we have our little protocol. One nice thing about this is actually all 4 of these things have really nice defaults. right? So if Swift lets us have default implementations for any method or property in a protocol. So we can actually just go ahead and make an extension. The default for additional headers is no headers. The default for before send is do nothing. Default for after success, do nothing. Default for after failure, do nothing. That's really great. That means that anybody who wants to create one of these request behaviors, they don't have to worry about implementing every single method and maybe like doing nothing. They don't have to implement the methods they don't want to implement. That's pretty good. So then there's another thing we can build, which is what we would call an empty request behavior, right? I want a request behavior that does nothing. Why would I want that? That's pretty weird. Aren't the point of request behaviors to do something? Well, the benefit of having an empty request behavior is once you have an empty request behavior, you don't need nil anymore. You don't need a way to signal that I don't want to send something here. I just want nothing to happen. So if before you had something like this where you have a send method, takes the request, same as before, and it also takes a request behavior, without empty request behavior, you might have it take nil as its default parameter. And if somebody doesn't want that work to be done, they'll just pass nil. And then it reads weird. It says send request with nil. Nil what? Send request. I need to send it with something. What's nil? But if you go ahead and change that to use the empty request behavior, you can actually take that question mark and poof, it's gone. And so now we don't have to worry about optional handling anymore. Now our code sort of handles the optional for us, and we don't need to think about the optional. So that's one little tool that we can build for ourselves. Here's another one. This is called combined request behavior. And what this does, this holds on to an array of request behaviors. And I'm not going to go through all the code, but it basically lets you treat many request behaviors as though they were one request behavior. It can merge all the headers together. It can perform all the before sends in order. It can perform all the after successes in order, and so on. So it can let you treat many request behaviors as one request behavior. So that's pretty cool. What does that let us do? Once you have combined request behavior, now you can take things that used to be arrays of request behaviors and you can treat them like they're just regular objects. You don't need to worry about them anymore. So do we have anywhere where we have an array of request behaviors? Yes, we do. So before, we had to think about an array of request behaviors, right? Anytime we wanted to use it, we had to get at the objects inside that array first. But with our new tool, we can actually just wrap all of those into a combined request behavior. And now that array itself behaves as though it were a request behavior on its own. And then the code just falls out. It becomes so simple. We can get rid of all of those for eaches and all of the moving parts, all of the complexity that we had, the auth token, the identifiers, whatever else behaviors we want to throw in there, the array, all of that has disappeared. All those moving parts are gone, right? And when those moving parts disappear, so do our branches. Our branches are just gone. We're back to the same number of branches that we had before. So that's step 3. Once you have your abstraction in mind, you can kind of start building these commonalities, these tools, anything that can be shared with all the different parts of the abstraction. And then step 4 is to actually do the work, right? So we want to actually extract our code. I will walk through building one of these. The other ones you can find on my blog, or you can come talk to me about it. We can build the auth token header behavior. All we need to do is implement additional headers. We don't need to implement anything else. We need access to the user defaults singleton, right? We need to check if the auth token is there. If it's there, return it. And if it's not there, return nothing. So this will always log us in exactly how we want. Now, why is this code good? Right? Why is this so much better than the code we had before? Well, one, it has one singleton, and it's easy to extract that, protocol, do whatever you want to do. It's right there. The other thing is that it only has 2 branches, right? Before we had 96 branches. Now this you can test on its own. It only has 2 branches. Either the auth token is there, or the auth token is not there. There's no other situation you have to test. If you write 2 tests, this class has 100% code coverage. And that is pretty cool. I won't go into the details here, but network activity indicator behavior, background task behavior, these are things that you can build as well. Their implementations sort of fall out from the protocol itself. So that's the sort of extraction step of the process. So yeah, once we're done with abstraction, then what? Well, now we can kind of reap the benefits. What have we gained here, right? We build extra stuff. stuff that wasn't obvious before. But now that we have these request behaviors, there are things that are so easy to add that we can just add them. It seems really useful to be able to just log every failed request. That is super easy to do. And it doesn't add any complexity to your network client. Before, you may have had some hesitation. I really want to add another logging thing here. I can't really test it. I don't know when this code's going to get hit. If it breaks, like, how am I going to know? Now you don't have to worry about that. Now you don't have to worry about that because the request behavior is super simple to write, and you can just toss it in that array, and you are done. Right? Again, easy to test. Take that singleton, pull it out, and write your test. Another super interesting one, maybe you want to know how long your tests take to run. You want to have a timer, how long your requests take to execute. You want to have a timer. Before, this would have been really ugly. You would have had like an NS timer or something insane, and then you would have like written all this code, and your network client would have gotten ugly, and you never would have done it. But now it's super easy. Before you send the request, grab the start date, right? When did the request get sent? And after you finish, whether it's success or failure, you're going to want to log something. And what do you log? Well, you log the time interval since right now. So you figure out how long ago your start date was, and you log that. Maybe you want to check if the requests are taking longer than 15 seconds, send it up to some kind of server for monitoring, something like that. All of that becomes super easy, and all of that becomes possible again, without making your original network client, which was so beautiful, more complicated, right? So we built this abstraction. Why did we do it? What did we gain? Well, one thing we gained is we gained decoupling, right? We were able to decouple the network client code from all of the other extra miscellaneous things that it also needed to do, right? Why do we like decoupling? We like decoupling because it lets us build boundaries, it lets us build borders between our different pieces of code. Once you have those borders, then you can start to handle your different pieces separately. So you can test your auth token behavior separately from your network client, whereas before you had to test them together. Testing is, right, so when I use this word handle, I mean a couple specific things. One, which I've already mentioned, is you want to be able to test your code. And looking at this again, we've run through it, but there's two branches here. This is very, very testable, right? Inject a fake user defaults, write your two test cases, and you're done, right? So that's the first way that we can kind of handle this code. Another way we can handle it is we can reuse code. This wasn't really available to us before because our, let's say our network activity indicator behavior was locked up in the network client. Let's say you have another architecture. Let's say you also need to send requests from some CocoaPod for some third-party service that you use. But you want that to show up in your network activity indicator. It's now possible because that code has been separated, right? So you can reuse that code where you couldn't reuse it before. So it's really important. And the last one is a little bit softer, but I really think it's important, is that I want to be able to just glance at my code and know that it's right. I don't want to dig through hundreds of lines, thousands of lines. I want to just be able to look at something and say, of course that's right. I know that's right because I can look at it, I can kind of ingest all of it without having to scan my eyes, scroll the page, Command F, grep through my project. I know that this is right, and I don't have to worry about it. So to kind of close up, there's a quote from Pablo Picasso. He says, "There is no abstract art." And as we all know, code is art. You must always start with something. Afterwards, you can remove all traces of reality. And that's what we've done here. We've started with some code. We didn't start with nothing. We started from code that wasn't working for us. We didn't try to create this abstraction before we actually had any real-world usage of the code. We waited until we had something in our hands. Once we had that thing in our hands, it was possible to take the code, remove all the traces of reality, and end up with a beautiful abstraction. Thank you.
Thank you so much, Soroush. We have one question.
Cool. One question. Add header is only being implemented by one class. Isn't it a waste of power to loop and call add header? So that's a really good question. And it is true that in our particular case, it was only being called by one class. But the thing is that there's going to be lots of different request behaviors. So I worked with a client who needed to sync data, right? So I have a consulting business and I work with lots of different clients. They have weird needs. They have very weird needs. So one app, it would send requests to the server and it would check the status code of the response to determine if that sync request was working or not, right? And so it would check, like, is this a 200? And if it's a 200, then I'm in good shape. The problem is, if you go to Starbucks and you sit on the Wi-Fi and there's a portal in your way, you're going to make a request and it's going to give you the portal page back, and that's going to be a 200, but that's not the page that you asked for. And so it would look like that was a successful request, but it wasn't. So what we did, we built a special request behavior that would create a little token, and we would send the token up as a header, and after it came back, we would check that that token was still there. And if that token was still there, that meant we were talking to the right server. If the token was missing, then we knew it was Starbucks doing some shenanigans. So it's true that, yeah, in this particular case, as we were developing the abstraction, we only needed the headers in one place. But as you add more of these and as you sort of abstract them even further, then you realize that no, lots of different behaviors need headers. They need access to the headers. And so it's useful just to throw it in there. Cool. Yeah. So did anything come in, or is that possible, or are we good? Okay, cool. If anybody has any questions, I think we can wrap up early too because we're running over.
Okay.
Yeah, that's fine. And if you have questions, I'm around today and tomorrow, so come find me, ask me questions, and I would be happy to answer them.